what we want to do here is recall from Calc 2 and physics what work is, and then from linear algebra how we expanded that just a little bit. Remember in Calc 2 that work was defined to be force times distance. I was told that it took physicists about 10 years to argue about how to come up with that. So that's not something that came down from the mountaintop. That's something that people thought really, really hard about and fought about for at least a decade. Meanwhile, but that only works if the force is actually going in exactly the same direction as the distance. In your linear algebra class and earlier this semester, we tried to do this a little bit more generally. So if you had a force vector going off that way and a distance vector going this way, how much work did the force do pushing something in a direction that was slightly different? What we did is we used the projection formula, and we know that the length right here is the force vector dot the distance vector divided by the length of the distance vector. So this is the amount of force that's actually going in that direction, and now we can actually use our definition above, saying that the work done is the amount of force that's actually going in that direction times the distance it moves. Remember, so we're not multiplying by the vector, we're multiplying by the distance. Then the distances just cancel, and we just get force dot distance. It looks like that, and even looks like force times distance, which is great. A couple things. Remember what the definition of dot product is, right? So this should be the length of the force vector times the length of the distance vector times the cosine of the angle between them. And the only reason I bring this up is that cosine is positive sometimes, cosine is negative sometimes, and cosine is 0 sometimes. We're going to say that the work done by the force vector is positive if the cosine is actually positive. So what I think a good way of actually thinking about that is we're going to say that the work done is positive if the force vector actually helps us move something from this direction or this direction. We're going to say the work done is negative if the force vector works against us as we move something from here to here. And we're going to say that the work done is 0 if the force vector doesn't work against us and doesn't help us move something from here to here. Now, we're going to want to generalize that because most force vectors aren't constant as you move from one place to place. And usually you don't try to move something in just a straight line. So in the next video, what we're going to do is look at a vector field full of different force vectors and just try to generalize that little principle that the work done is positive if the force vectors help us move something from one place to another. The work done is negative if the force vectors work against us as we move something from one position to another. And we're going to say that the work done is 0 if the force vectors don't help us nor hurt us as we move something from one position to another.